All right, so we left off here. We had used StatCrunch to kind of cut out the middleman, if you were. But again, you don't have to do that. You can do a double sort in Excel and do it that way, whatever. And then I'm going to find the totals, even though I already know what they are. I can see it from Excel, or excuse me, from StatCrunch below. But that's all right. If you wanted to find it longhand, this is how you do it. Right. Okay, and notice there's only 50 total, despite what the problem said there was 52, but the problem lied. All right, and again, I changed my table here just to kind of match what StatCrunch was giving me because I figured, why not, right? Okay, so while I'm on it, this is the observed. So let me add in something here. I'll just put it over here. This was observed, what we really see happening, okay? And then the question becomes, what do we expect, right? The expected table. So what I'm going to do is I'm going to make some space here. I'm going to insert, shift the cells down. I'm going to type up what my expected is. Now you could do it longhand or you could do it shorthand, right? So it's still these values right here. Oops. Now you can do it like the way they did it. So you take equals 21, give that an F4, so it's $, times 23 divided by the grand total of 50, give that a $. And then I can drag that along the row. But notice they're the same numbers I came up with down here due to StatCrunch. See? It always helps double check. And then this one would be 29, give that $, times 23, don't give that $, and divided by 50, give that $1 as well. And then I drag across. All right, so there's my expected, there's my observed. Now for the contingency table, I'm going to pop all this down just a little bit further. And I'm going to find the test statistic. Not all of it, but I know that I'm going to need parts of it. So I want observed minus expected squared divided by expected. All right, so let me do that. Hold on one second. Okay, there, my table's prettier now. Okay, so it's equal to observed, which was 13, take away the expected, which was 9.66, square it, and divide it by that expectation. There we go. And then I can just drag and drag. Because I made the tables identical to this and right above it, dragging will work in this case. Now this isn't the test statistic, this is just the table to find the test statistic. Speaking of which, we're going to need a null and alternative hypothesis, don't you think? Because I bet you, okay, so this part right here was what they asked for part A. So I better highlight it so that way the teacher knows that I know what that was. So this is part A. Okay, then for part B, I'm betting they're going to have us conduct a hypothesis test because that's just how they are. Let's look and see. Yep, test whether the gender is independent of drop reason at the alpha equals 0.10 level of significance. Alrighty. So step 1. This isn't a test for independence, by the way. The other one was a test for homogeneity in 11.2. So this is gender and drop reason are independent. That's what we assume to be true. The alternative, be gender and drop reason are dependent. Okay. Step 2. Step 2 is don't do that. All right, step 2. All right, alpha is 0.010, I think it was. All right, you know what? Before I go any further, I'm going to find, yeah, I'll do it right now. Degrees of freedom, because I know I'm going to need it. It's, let's see, I have 2 rows, so 2 minus 1 times 3 columns, 3 minus 1. Number of rows times number of columns. All right, step 3. Your test statistic. That's equal to the sum of all these bad boys. That's why we found that table in the first place. Oops. Let me move that over. That's your test statistic. It's chi squared sub 0. So it's chi 0 square. All right, we'll be back here for step 4, the classical NP value ways.